you're working on a bunch of like futuristic vision for decentralization and the architecture of Web3. And Eric Dawson, you actually are working at Nvidia, and you're also working on some futuristic visions for computing for the future. So my first question would be pretty simple, actually. I'm going to start with Eric. What are the bottlenecks actually in computing and AI at the moment, according to you?
I mean, it's a complicated answer to what seems like a simple question, I guess. But yeah, I think a lot of it is both in the software side of things. Certainly AI in general is so new. And, we think about code bases that really run the world. They're 50, 60 years old sometimes. You have all these COBOL banks, codes that are running and have been optimized. And a lot of that hasn't been done yet in the deep learning world. So that's kind of sort of round one. And then beyond that, we're moving so fast that I think a lot of places aren't taking the time to really optimize the compute all the way down to the hardware level. I think that's changing really rapidly. But, we're kind of playing catch up in a way.
Yeah, and for the decentralization then, like what are the bottlenecks when it comes to talk about AI and decentralized architecture?
Yeah, I mean, there was a really good talk I saw recently from Haseem from Dragonfly Capital, and he lays out, I think in a really profound way, the scale difference between what we expect from blockchains today and what we expect from machine learning and AI and large language models. And he gave an example of how it would cost $10 billion to do a single computation on a single row from an LLM. And when you're actually using things like ChatGPT, it's doing tens of thousands of those per symbol that it's spitting back out at you. And so, the orders of magnitude difference in what blockchains today are capable of and what AI is expecting, what it needs in order to do this amazing cutting edge thing that as early as 5 years ago, a lot of people were saying computers couldn't do. And so we're we're talking about massive improvements in throughput before it's realistic to execute AI on blockchains. And so I think when people talk about blockchains and AI, they really need to be thinking about other ways that those technologies can work together rather than just running the AI.
And I know that Eric, actually, you've been working at solving some of those bottlenecks from your side. So you have a background as a biologist, right? So can you talk a little bit more about what you are developing at the moment and what are our key research?
Yeah, I mean, the space is super busy, and I think actually a lot of my work comes down to making community models faster, easier to use, and really pairing them up with hardware. Working with folks out there. It's a big open community in science, luckily for the most part, and I think some of the magic of it is you don't have to invent everything yourself. People come to you and they're like, "Hey, can you help us do this?" and kind of build on that. But we're seeing sort of this explosion in the amount of AI models across the space. You look at single cell or even just in the genomic space, absolutely massive increase in these things. And at the same time, a lot of, what I'm interested in and what I'm trying to work on sort of in my evenings and things like that is how do we make these things more efficient and how do we make them more both beneficial for humanity, but also for the planet, really thinking about how do we do things sort of in concert with nature in a way that respects individual privacy and sovereignty of the rights of people to have control over their own data. And it's a super interesting space right now. I see that all at once.
And so are you within the lab of Nvidia, or with who are you working there? What are the key scientists? Do you prefer working with biologists? Do you have some needs also to make this feel developed?
I mean, I love, one of the things I love about, working in this space, like I said, is we work with everyone. There's no one who gets told no. And I think that that's actually really special. As long as someone comes in and they're like, we need to make this faster or better.
Yeah.
In general, the team says yes. And I think that's such a special part of it, actually. So I can't say I only work with biologists or anything like that because it's biologists, chemists, statisticians, mathematicians. It really does span, when we talk about interdisciplinary, distributed science, when you get on a Zoom call and there's 50 people from 30 institutions and, 9 different degrees represented within it. It's a really special feeling.
And so, Deter, one of the biggest advantage of GPUs for AI training is the ability to run many computation in parallel, right? And unlike many blockchain architecture, which are typically linear models, right? Is it possible actually to achieve parallel computing? Because that's one of the main bottlenecks, right? If we want to bridge AI with blockchain.
Yeah, it's interesting, and the way that we get security in blockchain systems is that we have multiple machines recreate the same computation and ensure that the result is the same at the end. And so that means that we have to build our system such that there's no sort of implementation specific differences in how they do the computation. And then there's like an ordering, right? So most systems where you do parallelism, there's a little bit of a fudge factor where if you do this thing first and then you do that thing versus if you do that thing first and then you do this thing, you might get slightly different answers, but they'll be well within the margin of error. But in a blockchain system, we can't accept any error, no matter how small, because we don't know whether or not that error was intentional by someone trying to defraud the system. And so everything has to be exactly bit accurate. And so we're doing research right now at Flow on how we can extract parallelism from the transaction stream. So we have transactions coming into the network, and we can process them quite quickly. But when you're dealing with millions of users all trying to use the same system simultaneously, that you start to need to be able to break them up into parallel streams. And so, I don't think anyone's talking about getting to like sort of the millions of parallel executions that are happening in GPUs on the blockchain space right now. But even if we get to 10 or 100 parallel streams of execution in a blockchain, that can add up to 5 to 50 times sort of overall execution throughput increase. And I think a lot of these systems, the inverse of throughput is cost, right? The more that the blockchain can do in any given unit of time, the less it has to charge for doing each one of those things. And so that's a real big concern in these systems. And so Flow is trying to work ahead to optimize both the linear path, but also extract parallelism from the transactions that don't impact each other.
Awesome. It's a question for you, Eric. Do you see any future on like the intersection between blockchain and AI?
I mean, we're talking about it today, certainly. So,
Yeah.
I think obviously, I think there's a lot of people that share an interest in the same 2 spaces. And so I can't imagine that there won't at least be experimentation in the near term. And certainly, I think something could pan out. These are both things that we know have practical uses and that have become increasingly useful over time, I would say. I know a lot more on the AI side than the blockchain side, to be totally honest. But, I can't imagine, the flow of information and the production of knowledge out of that information can't be linked in some way. I mean, Deter, you're the expert in this, you're so.
Yeah, I think about this a lot because I think, for me, the most exciting aspect of AI, at least in the nearest term, is I see it as a complete revolution in user experience. Personally, the value I've gotten out of AI is getting information for myself. And it's information that I could have got on the internet. That's how it got into the AI in the first place. But finding it isn't always easy. Summarizing it isn't always easy. And the ability to go to ChatGPT or some other similar service and say, hey, how does this thing work? And it gives me an explanation. And I can dig deeper on the areas I want without having to go to 10 web pages to find the one web page that goes deep on the area that I'm having trouble understanding. And I think with blockchain, it falls right into that, right? Like, how do I use a blockchain? How do I interact? Learning anything is going to be easier with machine learning on your side. And blockchain needs that. There's also really interesting ideas around potentially independent agents acting on your instructions, right? Whether it's because you're asleep or because you can't react very quickly. But I think the thing that's not talked about very much, and you might have some experience with this, Eric, is there was some research done when image identification was all the rage in machine learning circles, right? Here's a picture. Is it a picture of a horse or is it a picture of a dog? There was some interesting research that showed that if you change a single pixel in that image, you can force the AI to give the wrong answer. And not just the wrong answer, but a wrong answer with very high certainty. So you could give it a picture of a horse, and it'll say that's a horse. And then you change the color of a single picture in that image, and it'll say, I am 99% sure that you are showing me a frog. And when you think of that in terms of investment or transactions or any sort of financial interactions, we have to be really careful. When we're designing blockchains, we're constantly thinking about adversaries. We're constantly thinking about what happens if someone tries to attack this system. And in the AI space, we don't think about that very much. But if you start putting AI and blockchains together, if you're not thinking about that adversarial side of things, you could run into a lot of trouble where you show it a transaction and it says, oh, this is going to give you a free NFT, or this is going to get you to sign up to this service, when in reality, it's going to drain your account. And it could be a change in a comment, it could be a change in a variable name, that would map to that single pixel changing. So as a human looking at it, you wouldn't see the difference, but as an AI looking at it, could get completely the wrong answer. And so I think it's going to be really interesting to see how we can leverage these systems without putting too much faith in them when there's money on the line, because there's the opportunity for attack, but there's the opportunity for gain from the attacker. And I guess people don't change pixels in their images very often to try and fool an AI because they don't make money out of it. But if I can trick you into giving you your life savings, that's a different story entirely.
Okay, that's super interesting. Thank you. And when it comes actually to talk about moonshots, what would be your moonshot if we think about biotech, biology, AI, and what would be your moonshot if we talk about AI and decentralized architecture?
You want to go first?
Do my best. Yeah. I talked today about sort of how do we get to carbon neutral computing, and I think that's a remarkable landmark. But actually getting to carbon negative storage or computing is sort of the moonshot that I think of as if we're compute constrained and we're energy constrained now, and a lot of people are arguing about whether we're compute constrained or energy constrained. We may be in that sort of transition point where suddenly we have enough compute power in the world, but we actually don't have enough power to run it all. Then to turn that around and say, well, actually, the more you store, the more carbon you sequester, or the less energy you use, you really change the paradigm of how you go and seek out opportunities for compute, what you do with all that. That would be my moonshot. If I could, put some absurd number of zeros on a check and do that, I think that's what I would go tackle, because I think it just changes the way that both people think in the short term and, really think of that long-term thinking about if I want to do generations of computing and I want to solve some question that's going to take who knows how long, maybe 3 or 4 lifetimes, you really change the way that people interact with those systems at this point and what those systems learn and do for us. And I think or do with us. And I think that's I think that would be a super fun moonshot to go tackle.
For sure. Very interesting. And what do you think about organoids actually being able to compute and all this field that is being actually developed at the moment, right?
Yeah, I think it's so interesting that people are exploring it. We've sort of been silicon dominated for decades, and it's the chips are incredible and essential. And I think the space right now clearly is filled with a ton of creativity, and you're seeing all of that come out in these sort of ways that people are exploring new designs, new ways of interfacing with them, and even new media like that. And so, I don't know what the future holds with it, but I find it so interesting that we're even asking the questions around it. And I think it's actually really inspiring to, think out, to see all these folks thinking outside the box and really taking on what are incredibly hard questions about changing the paradigm of computation.
Nice, thank you. What about you, Deter?
Well, in some ways, I think my moonshot's a little less ambitious. But also, I think it is transformative in its own way, and it's literally just getting people to use blockchain technology for what it can already do, but outside of the financial use cases, right? And I don't want to make it sound like I don't think blockchain should be used for financial use cases. Of course it should. It's good at that. I wouldn't want to stop anybody doing. Well, some people I would want to stop, but most of the activity I think is totally fine. But it's weirdly overshadowed a lot of really other interesting ideas that we've had in terms of what we can do when we have a computer that anybody can access, everybody can trust, but nobody controls it. Nobody can shut it down. Nobody can make it work in a different way. And and we talk a lot about our concern about platforms and whether or not we own our own data, whether or not we own our own processing. And one of my favorite lines is that the cloud is just a fancy way of saying somebody else's computer. And what's neat about a blockchain is it's everybody's computer. And that means that we share it, right? What I'm doing, can interact with what you're doing, but it also means that there isn't some government, corporation, consortium, industry consortium that can control it and shut it down. And I think that really is the cure for a lot of ills that we're feeling right now in our current world of computation.
Nice, thank you. So that's going to be my last question, and that's also an invitation for you to have maybe a call. What you feel needs actually to develop and reach all those goals and those moonshots? Is it, you mentioned a couple of zeros on a check, but maybe you need something else. So yeah, because all this conference is about field building, what is your need right now to be able actually to reach your target?
It's a very targeted question. It's good. I think, imagining that, you want to do carbon negative data storage, say by storing data in DNA and then putting that DNA in plants. Turns out we're really good at reading DNA. There's lots of technologies out there for doing this, all sorts of sequencing, multi-billion-dollar sequencing companies, a huge industry. And yet we're not very good at writing it. We explore it, we do it, but that throughput to really do it at scale and all that isn't quite there. So there's always some little piece that's missing, but it's funny because, like you said, we're here for field building, and it means that if someone comes along and all they do is make one incremental piece that they give to the world, suddenly that whole chain of events becomes possible. And so I think that's what's missing is really, the synthetic bio folks and our understanding of how these systems even work is still evolving. Scientists are still employed for very good reason because these are very hard problems. And so, yeah, I think that is the sort of linchpin that's waiting to, make my moonshot happen. It's not just money. You could throw infinite money at the problem and you still might solve it. Given infinite time, you might solve it. But, really it is we need a little bit of technological advancement in there and really thinking outside the box and doing something that has never been done before to make that whole process exist and possible and maybe one day even commoditized.
So more scientists and technologists really focusing on this particular area.
Yeah, I think feeling free to have that creativity around, I'm not just chasing, replication is essential, obviously, and you need to be able to produce results, but not just chasing what's been done before, but, having the support and the sort of mission statement to say, I'm going to go chase something that's actually never been done before and I'm not sure is possible. That sort of risk sometimes is discouraged because it is risky. These people put their lives, their careers, the well-being of their families even on the line, to go do these things, their reputations. And I think having a space that they can do that is really important to human innovation.
Nice. What about you, Deter?
Well, it's funny because, as Eric started talking, I was just sort of starting to formulate my answer. And then I realized that what he was saying, there's a lot of commonality in what I was thinking and what he was saying, because at the end of the day, what we really need for my problem, but I think for Eric's problem, is for people to take seriously that it can be solved, for other people to take seriously the idea that it's worth solving, right, and to invest in them, provide the resources and funding that they need, and then for the human creativity to flourish in that area. And obviously, it's different. It's a different problem. It's a different kind of creativity that's needed in each case. But I guess that's ultimately the problem with humanity is that we only have so many resources to go around, and we've got to try and pick and choose. And so, I make the case here that more people should be putting creativity into new blockchain use cases that aren't necessarily the token of the week, but actually are creating sustainable businesses that create real user value over the long term. And I imagine Eric would encourage people to put their time and energy into looking at more naturalistic ways to do computing and get out of this rut of just building bigger and bigger data centers that take up more and more electricity. So
I'd say even anything that inspires them, like go chase it, you know, and I hope that I hope everyone gets that opportunity in their lifetime. It's such a special thing to be able to chase what interests you. And so whatever that is, like, I hope everyone gets that chance.
Great.
It's so special.
Thank you so much. Thank you.
thank you very much, Alex.